Okay, so we're back and we're going to go over this 5.1 problem. It's just this last little bit, and we're going over systems of equations, okay? Systems of equations just means I have more than one equation, okay? So it says both paint companies allow customers to purchase their own paint supplies. Carlos has done some research and found the following information. Handyman Tools and Supplies sells small painter's kit that contains 2 paintbrushes, 4 rolls of masking tape for $16. They also sell a large painter's kit that contains 5 paintbrushes and 15 rolls of masking tape. Carlos's dad is planning to paint a couple of the rooms in their house and is offered to buy any leftover supplies. Carlos is trying to figure out how much he would charge his dad for each paintbrush and each roll of tape. To keep track of the information, he has followed this. Okay, so take a second. Don't just rush into the problem. What is this saying? What does the P mean? Why are they adding? Why is there 2 P's? Why is there 4 R's? Why is it equal to 16? These are the questions that if you take the second to figure this out, it helps you understand the bigger picture. So don't rush into problems. Take a second. What does the 2P mean? What does P mean? Any guesses? What do you think P means? Yeah, paintbrushes actually. So P means paintbrushes. What does R mean? Very good. Rolls of tape. So this is talking about the 2 paintbrushes. So here, let me highlight for you. This guy is talking about this guy, right? Versus this guy is talking about the second equation. Everybody so far so good? Yes? Okay, so there's a couple ways for us to go. If you remember from last year, there was another way that you can solve this problem called elimination, but we are staying on substitution, okay? So substitution says, hey, I want to get to the point where I can substitute into the other equation, right? I want to get to the point where I can substitute into the other equation, but I can't right now because why? Anybody see why I can't substitute into the other equation? Yeah, I can't substitute into because, like, remember the one that we just did, right? I'm over here with this. We just did this problem over here. Oh, I went down. I was going up instead of going down. My bad. So we just did this problem right here, right? And the reason why we could substitute is because we had y solved for. Does everybody see that? Is y solved for in this problem? And the answer is not yet. So we can't do it that way. Can we plug, Miss Johnson, I know we can graph it, right? And you're like, okay, well, let's try plugging these in. So I'm just going to make this guy X and this guy Y. I mean, you can do 2P plus 4R equals to 16. But see, you can't graph it. Desmos doesn't know what you're talking about right now because neither one, you're like, oh, well, maybe if I do X and if I do Y, that's better. So when you're plugging stuff into here, Desmos is okay with you plugging it in as long as this happens here. Everybody good? Okay, I am going to plug in the second one. So here goes 5P plus 15R equals 250. Did I do that right? And then I said, no, Miss Jonathan, you got to use X, remember? And I say yes, and Y. And then so you're like, but Miss Jonathan, where is that equation? There it is. What's the most important part, y'all? What's the most important part? Say it. Yes. Thank you. I loved it. In unison as well. So I'm going to take a snip of this just so that we have this on our notes page. Where's my snipping tool? There it is. There you go. So there's my snip. I'm going to copy that and put it right here. Make it a tad bit smaller. There you go. Okay, so let's answer some questions. We already answered this. What does P and R stand for? Good. Clarita says, I think I can find the values for P and R using a table or graph. Here is our graph. And then Carlos says, I think I can find it using algebra. Solve for P and R both graphically and algebraically. So here we did it graphically, but now we have to do it algebraically. So algebraically, it's going to look interesting. But the very first thing that I need to do, let me see if I can do this. And I'll just write it right down here. Okay. So the first thing that I need to do is I need to get either the P or the R by himself. Any ideas on that? And I'm going to write them next to each other. 5P plus 15R equals 50. Does anybody see anything pretty like neato about these equations? So 2P plus 4R equals to 16. This one says 5P plus 15R equals to 50. Does anybody see anything pretty neato about these equations? So look for a pattern, look for something that you notice, look for it. Anybody see it? Come on, y'all.
We both think P and R.
Good. That's number one. Number two, does anybody see? Yeah. Someone says this equation has a bunch of somethings in it. I'm not even going to tell you what she said. Someone said this one has a bunch of somethings in it. What does this equation all have in it? Yes. Very good. This one has a bunch of fives in it. Who saw that this one has a bunch of fives in it? Okay, if you didn't see it, that's one of your first tasks. Can I make this guy smaller? And the answer is yes. How do you make him smaller? Well, math says that I can divide every single piece, both sides, by the number 5 and it make it a better equation. Right? So, Ms. Johnson, what? Yeah, so divide this by 5, divide this by 5, and divide this by 5. Ms. Johnson, you could do that. That's a legal tip in math. Yeah. I don't know. Here, you try it. I'm going to say a true statement. 2 plus 6 equals 8. Is this a true statement? 2 plus 6 equals 8? Good. What number do you see in all of these? What number do you see in all of these? What number do you see in all of these? Yeah, a 2. So try it. Divide by 2, divide by 2, and divide by 2. What's 2 divided by 2? 1. What's 6 divided by 2? 3. What's 8 divided by 2? 4. So this is how you play to see, wait, is it legal to do this? Now, you didn't prove that it's legal to do it in all cases. You just saw that, okay, that makes sense. I could take half of this plus half of this and I should get half of this, right? Like a context of the story would be like, I paid for 2 things of French fries and 6 burgers and it cost me some money. But if I got half of it, doesn't it make sense that I would essentially be paying for half of it? And the answer is yeah. So do your best to write this equation out. Don't forget your P's and don't forget your R's. Write your equation out here. Okay. So you should have wrote something like this. P plus 3R equals to 10. P, where'd you get P from? Because 5 P's divided by 5 is a P. 15R divided by 5 is 3 R's. 50 divided by 5 is 10. Okay, do the similar thing here. Do a similar thing here. What number do you see in all of these? Great, divide it and do this. Huh?
Those?
Yes.
Cannot be divided.
So then write your equation. Don't say it out loud. Just write your equation right here. 0p doesn't make sense to me. Person who put 0p, check your math on that. Now, is this going to work every single time, Ms. Johnson? No. No, it's not going to work every single time. But for the times it does, it saves you a headache. For the times it does, it saves you a headache. Perfect. All right, so I'm going to divide by 2, divide by 2, divide by 2. 2p's divided by 2 is p, plus 4r divided by 2 is 2r equals to 8. Okay, question. Is that the hard part? Dividing each piece by 2, is that the hard part? No? Okay, good. So again, I still don't have it. What I would really like is for me to be able, again, I can't show you this. Where is that? Oh, I go this way. I want it to say, like it did over here. I wanted it to say y equals. I want it to say that. Does anybody know how I can get it to say like, well, it's not going to say y equals because I don't have a y, but that I can get one of the variables by himself? Like, who would you get by himself, p or r in this equation? Who would you get by himself, p or r? Yeah, I get p by himself, not r. I would not get r by himself because, right? Like, think about that. You'd have to subtract p and then divide by 2. And now you're dealing with fractions. If you want to deal with fractions, go ahead. But I told you, there's certain things that I prefer not to deal with. All right, what would you solve for in this one, p or r? Yeah, it happens to be that I would solve for p in both of them, which is a really good thing. So I'm going to solve for p here. I want to get everybody away from p. So what's happening to p? Who is with p? Someone says it's being added to 2r. Okay. Anybody know my next question? How do you, what's that word that I use? How do you undo? How do you undo plus 2r? Yeah, how do you inverse it? Yeah, what's the inverse of adding 2r? Yeah, subtract.
Subtraction.
Perfect. Subtract 2r on both sides. Hurry up and do that. For those of you, I see you taking notes and getting this. Good. Good job. You're only going to get better at this with your effort. I promise you. If you do the things that I've been telling you to do, it'll work. All right, so I'm going to subtract 2r on both sides. Subtract 2r here. I go like this. I do not put them underneath 8 because those are not like terms. Okay, I'm not going to put them right underneath to set myself up for failure and go 8 minus 2r is 6r. 8 minus 2r is not 6r. What is 8 minus 2r?
It's just 8 minus 2r because they're not like terms.
Exactly. It's 8 minus 2r. And if this thing would catch up, you would see that p equals to 8 minus 2r. Okay. I'm going to patiently wait, and then I'm going to ask you, as now, what are you going to do with this information? What are you going to do with 8 minus 2r? Now that you have this, what are you going to do with 8 minus 2r? What are you going to do with this? There's several things that you can do, by the way. Some of you are going to do one thing. Other people are going to do another thing. I just need to hear your ideas. What would you do now? It says p equals to 8 minus 2r. What would you do now?
Or p is plug that in.
Yeah, he's going to substitute. Perfect. He's going to substitute. Now, some of you are not going to substitute. Some of you are going to do this thing where you get p by itself over here, and then you're going to substitute. Either way, it's fine. Because you already know how to do that, I am not going to do it that way. Okay. No, I wouldn't add 8. I'm just going to leave it just like this. And then I'm going to say this, the famous phrase, hey, instead of that bacon, can you put avocado instead? Instead of bacon, can you put avocado instead? Does anybody see bacon in the other equation? You see bacon? Yeah. So instead of putting bacon, I'm going to put avocado instead. So can you write that next line?
Can you get beef instead of bacon?
You can have whatever you want. I mean, as long as they're equal, it's fine, right? Okay, go ahead and write that next line. I'm going to pause it really quick. I am going to pause this really quick. All right, so here's the next part. Again, instead of bacon, I'm going to ask for avocado instead. And I could do that because they're equal, right? So I'm going to keep this equation exactly the same. In fact, I'll copy and paste it like this just because I want you to know it's going to be exactly the same, right? And instead of putting that P, I'm going to put something else that equals to P instead. So all of that equation stays exactly the same. What goes in here? And I'm going to use parentheses too because that way it's you know, there. Yes. Now you're going to copy this part, Miss Johnson? Yep. And I'm going to put it right in here. Let's scoot you over a little. Ooh, that's not good. Dude. Sorry, I really want you guys to see substitution for what it is, but it's not working. One more time. Oh, I could do this way. Am I doing this? I could do this. So I'm just going to plug everybody in because that's what I want to do. I like literally want you guys to see that this is just substitution. Yeah, that's pretty good. All right, let me clean them up just a bit. Right? So now I'm just going to simplify this. Now I transported you back to 8th grade. You should be able to solve this. If you don't know how to solve this, not a big deal. Just pay attention to my steps and remember them, right? So does anybody see that anything I could do right here? For those of you who already know how to do this, you're moving on. I'm doing these steps for the people who need them. So you're ignoring me if you already know what you're doing. I'm helping and supporting the people who don't know what they're doing right now. So if you don't know what you're doing right now, is there anything here that you see that can be simplified? Does anybody see anything here that can be simplified? Yeah, negative 2r plus 3r. Very good. These are called like terms. Everyone say like terms. Like terms, Miss Johnson. So like terms means I can put them together in a bucket. So what's negative 2 of something plus 3 of something? What's negative 2? Yeah, it's one of them. So I'm just going to keep this 8 because he didn't do anything. And then I'm going to put these two together. And if I combine them, I get plus r. If you want, you can put plus 1r, right? But I'm going to definitely put an r. Equals to, I don't know why I keep writing slanty, but there you go. 10. So now I've transported you back to 6th grade. This is a problem that you guys have been doing since 6th grade. Actually, if I really wanted to, I can transport this back to kindergarten, right? Instead, in kindergarten, can you guys hear me? Okay, hold on. Can someone type in the chat? It's okay. You can leave and come back. That should fix sound. Okay. So this is back in kindergarten, right? They used to say problems like this. What? No, 8. 8 plus what gives me 10? Right? Do you guys remember these back in kindergarten? 2nd grade? They put a little box. You guys are in 9th grade? We're going to put a letter. Here, I'll show you what I mean. Kindergarten. Right? 9th grade? 9th grade. So your teachers have been teaching you algebra since like way back when. And the only reason why it's an R now is because we can do more things with R's, right? Or variables. So what's R then? Yeah, R is 2, right? Some of you will subtract 8 from both sides. Some of you just know R is 2. right? So now I have to push you back into ninth grade. You would be done in sixth grade, kindergarten, whatever, once you said, oh, my answer is 2, right? But now putting yourself back into ninth grade, what do you do? What do you do with this r equals to 2? It's supposed to say r equals to 2. Not sure why it's not catching up to me.
Substitute.
Yeah, we substitute again. So notice what we did. We solved, we substituted, we solved. We're going to substitute and then we're going to solve. Ms. Johnson, the only new step here was we had to solve for one of the variables? Yes. So let me say it again. We solved, we substituted, then we solved again. Then we're going to substitute. So let me substitute. So this says P equals 8 minus 2 parentheses. And I literally take this 2. I like copying and pasting. I really do, because I think it's a physical thing that you guys are saying. She's just going to put that 2 right in that spot. Yes, because r equals 2. Right? So there, let's say it again. I solved. I substitute. I solve. I substituted. Guess what I'm going to do next? Solve. So this is 8 minus 4. So therefore P equals to 4. So Ms. Johnson, you know how you wrote it as a point before, like X comma Y? Should I do that here? No, because it's a context, right? So this is, the answer is 4 comma 2. If you look up here, look at your answer, it's 4 comma 2. And so now you're just going to write this in a sentence. So P, so paintbrushes were $4 each, and rolls of tape were $2 each. Does that make sense? So if it's in a context, then give yourself the context. So which part of this was difficult? Was the noticing that each one of them was divisible by 2? You didn't actually have to do that, but you did have to solve it. So you would either divide here or you would divide later, but you would definitely be dividing. Was it that part? Was it like you plugging in you solving for a variable? Maybe, maybe not. Was it you substituting into the other equation? Was it you solving it? Which part here was the part that's confusing? Talk yourself through that part, right? Yeah. So I'll tell you right now, like, listen to the steps here's your rules in terms of substitution. Oh, I can't type right now. Am I not able to type? Give me a second. Let me grab another window. Where did it go? Oh, there it is. Sorry, let me just grab something else. Maybe it'll do it for me. All right, here we go. It's not letting me type. So weird. There it goes. All right, here's the directions on substitution. Ready? First, we solved. Solve for a variable in an equation. This is your choice, right? Which variable do you want to solve for? Great, do that one. So in softball or in baseball, we call this fielder's choice. You get to pick which equation, which variable you got to solve for. That's this area right here. You solved for P. Then what did we do? What did we do with this information? 8 minus 2r. What did we do with this? We substituted, right? We went right here. We substituted. Okay. So then we substituted into other equation. Okay. Once we substituted, what did we do from here to here? What did we do? Yeah, we solved again. Solve. This is back in, by the way, when you're doing this is back in 8th grade. Or even 6th grade, depending on what you want to talk about. Once we had r equals to 2, what did we do then? Yep, we substituted again. Again, Ms. Johnson? Anybody notice pattern? And then last but not least, yep, we solved. Ms. Johnson, for substitution, we solve, then substitute, solve, then substitute, then solve? Yes. You just keep repeating the steps, Ms. Johnson? Yes. Okay. So let's just go over takeaways really quickly. Oh, shoot. I wanted to go over it in yours. Give me a second. Let me pull this up. I know, right? Over and over again. All right, so here's your takeaways. I just want to go over them just so that we're all on the same place. So while each equation in a system equation has many solutions, the solution to a system of linear equations is, while each equation in a system of equations has many solutions, the solution to a system of linear equations is a point. Sometimes, yes. And then systems of equations can be solved using tables, graphs, or algebra. The solution to the system is revealed in different ways, and each strategy has its pros and its cons. So when we're using a graph, so reminding you, when we looked at this graph, right? Where do you look for the solution?
The point in which both lines intersect.
Good. Point of intersection, right? Where'd you go, buddy? Nope. Right? It's the point of intersection. The pros of this is that, like, you don't have to do any algebra work, right? Desmos does it all for you, right? Pros, Desmos. Cons. Anybody think of a con that could be? Yeah.
Like many other ways, if you get one number wrong, it goes like way off scale. And then you don't have the exact algebra, so if they're asking for certain steps, you don't really have them.
Yeah. Check this out too. Like, I drew in this green one and I want to turn off the blue one just for a second. Look very close. Use your very young, very precise eyes. What is the solution to that? If I didn't let you use Desmos, you'd be guessing like, I don't know, Miss Johnson, like 2.9 comma 2.7. I don't know. So when I click on it, it tells me what it is, but I was wrong. Everybody see that? But even so, you have to make sure that your answer is as precise as possible. So graphing is only as good as if the solution is something that I can pull off of a graph. Does that make sense? Using a table, again, same kind of deal. I can find the solution where the two numbers will match, right? It's kind of like a point of intersection, except for now we have matching numbers. And the same thing goes here. The pros is I don't have to do much math. Yes, absolutely. I don't have to do much math, but if it doesn't overlap in a way that I can tell, then I'm in trouble. Here's why algebra is the best. Number one, if my answer is some obscure number like 2.739, algebra is going to tell me. I don't have to guess. I don't have to guesstimate. I'm going to get it right. Okay. Last but not least, there are two methods for solving a system of the equation by substitution. One of the ways looked more like what we did in this last problem, where we solved for one and we plugged it into the other, right? And the other one, hold on a second, where is it? And the other one is what we did over here, where both of them were solved for y and we set them equal to each other. This one here. Okay. Both of those are legit ways for you to work. Okay. All right.